input section. And input is where we get to start working on reading the physical world. We want to see what's going on around us. And as we want to know what's going on around us, we want to be able to measure what's going on around us. And remember that the easiest way to do this, to measure the world around us, because the world that we live in is pretty analog, it's not so digital. And as we live in the analog world, we want to be able to read analog sensors and read analog data. And to be able to read analog data, we want to use the amazing function analog read. So if everybody remembers this, the important part is analog read, to read in analog sensors. Now what's very important when we do an analog read, we have to load the analog read into a variable. So what it's going to do is it's going to go out to the pin that we tell it to do it to. It's going to be like, what's your value right now? We have to tell it what variable that goes into. So the syntax, or the way we write this is, the variable, whatever the variable name is equal to, so the variable is analog read, and then what pin we're reading, semicolon. It's very important to remember, variabile è uguale a analog read e quale pin, punto verbo, in Italian as well. So, for example here, if we have the thermistor sensor declared as the variable thermistor sensor, I can say the temperature, so I created a variable called temperature, is equal to analog read thermistor sensor. So if we take a look at it in the code over here, we have the integer thermistor sensor. We made it equal to 0 at the beginning just to keep it from having problems. And we have the integer temperature, which we also made 0 to start off with. And then we void the setup, and we say that the pin mode for the thermistor sensor is input, because we're reading the thermistor sensor, so we want an input on the thermistor sensor. And then our program simply does this. It says, tell me, the temperature wants to know what the analog read on the thermistor sensor is. Very easy. And it reads it in directly. But we don't have an output. The easiest way to do output, and many people who teach Arduino leave serial for much later, but I like to teach serial at the beginning. Okay, here we go. Serial communication. I like to teach you serial because to get a sensor to work correctly, we want to be able to see what that sensor is saying. So the best way to know what a sensor is doing is by turning on serial communication. And what does serial communication do? Serial communication simply says from the Arduino, send a message back to my console. Keep sending me the message so I can tell it to say the temperature is this thing here. I'll show you that in this next slide. We need to do 2 slides. There are 3 different commands that are important for serial communication for us at this point. To start doing serial communication, in order to be able to do serial communication, in our serial port, we need to start the serial communication. So up here in our header, not in our header, excuse me, in our setup, we need to put the line in, serial begin, and then we have to tell it at what speed it's going to be running at. 9600 is a pretty stable speed. We can make the serial port run very quickly for complicated programs. We can make it run very slowly. But we have to tell it how fast it has to go. If anybody remembers the old BBS days, back when the internet was very young, our modems, we would have to tell our modems how fast they were going to run. It's the exact same thing. We're just making a serial connection to our Arduino, so we have to begin always with the declaration, serial begin, and inside the parentheses, how fast should it run? So we put serial begin 9600. Then, in order to get the Arduino to send messages back to our computer, we can use 2 different commands. One is serial print. And serial print just prints the value that we want back to our computer. So we can put for example, serial print value, and that sends that number value back to our computer. The only problem with doing this is that it just keeps writing the numbers one number after another after another. So that we have to organize our data just a little bit. And to organize our data, what we want to do is put serial print ln. And that ln stands for new line. So serial print ln gives you a new line of serial information. So it'll keep writing one line, and then another line, and then another line. So very important to know when to use serial print and when to use serial print ln to format our data correctly. So let's take a look at what we can do here. So we've got our same program again. We've got our comments up top. We want to read a thermistor. We have our input thermistor. We have our temperature as our integers. But here in void setup now, you'll notice that we have in here after the pin mode, we said that we want to begin serial communication at 9600. So that it starts sending information back to our computer. We do the same thing that we did before. We read our temperature, so temperature, analog read, thermistor sensor, and then we add these two lines at the very bottom of our code. We say serial print, and this is very key. Take a look at this. When you want to write something in so that the humans can read this better, you need to put it in quotation marks. So I put quotation, the temperature is, close quotation, and then I put serial print, new line, temperature. So our program at this point will say, the temperature is this, the temperature is that, the temperature is infinitely. Okay. Do we want to see this work really quick? So if I plug the hat in here, ooh, and this is going to be nice and hot because it's sitting underneath the fan here. Let's take a look at Arduino. Fantastic. Thank you, Arduino.
Thank you, Arduino.
Let's just make sure I've got the right board. So I have a 168 and you guys have 328s. And then I'm going to go and make sure that I've got my right serial port. All I should have to do at this point is turn it on. And here we go. He's saying the temperature is 224. Why isn't he saying anymore? The temperature is 79. He's a little confused. The serial communication can have a little bit of glitch when it starts. It has a little problem when it gets started. So you get some kind of value like 224. Don't ever trust your first line. In serial communication, the first line always comes out with a weird setting. But you notice that it started to kind of balance off here. 79, 80, 81, 83, 85. And it's just every second telling me what the temperature is. Because I put a delay for 1 second.
It's Fahrenheit.
It's not anything, and that's what I want to explain next. What does this number correspond to? What does this number mean? Because it doesn't mean anything. If we want to translate it into Fahrenheit or into Celsius, we've got to do some magic. That actually might be Fahrenheit, come to think of it. I don't know if this program has already been corrected. Let's give it a look-see here. Anyway, we'll talk about it in just a minute. Okay, let's talk about analog input for just a minute. Ricard talked about this a little bit yesterday, but this is where we're going to start to make a little bit more sense. Remember that the Arduino reads analog input from 0 to 5 volts. And that our different pieces change that voltage. It limits how much voltage gets through. So the function analog read simply takes that number that's anywhere between 0 and 5 volts and changes it to a scale of 0 to 123. Everybody remembers the stairs from yesterday? It's exactly what it's doing. And remember that it isn't actually reading in an analog sense. It isn't like this nice curvy line that we have here. That would be pure analog data. Because when we're telling it to read the temperature every second, it's reading it here. And the second it was there, and then it got hotter, and then it got hotter, and then it got hotter, and then it got colder and colder, and went down really cold and got hot again. So, if we want to adjust that temperature, and I might have already adjusted this out, What we have to remember, and this is the whole key to that stair lesson yesterday, is that it depends on which thermistor we're using. So you're going to kind of need, and I'll tell you, sometimes it's good to not correct this because our numbers are more precise when we're in the other scale. But what we can do is we know that in this particular thermistor, that every degree corresponds to 5 millivolts because there's 1,024 steps. So what I can do is tell it that when I do the analog read, to multiply that by 5 divided by 10, or times 0.0 or 0.5. So that's adjusting my number back out in the end. Why should we? This gives us a really nice number because it's something we can read. It's something that makes sense to us because it's the scale that we know. Why I suggest you don't use this number is because it's much more precise to have the numbers from 0 to 123 because the actual change is actually pretty close. So let me encourage you to go ahead and try to use it with the 0 to 120 or 1024 scale, just because we'll get better information to use when we start elaborating this. Let's take a look. And that's where we get to, elaborating. It's that easy. Serial input is really, really easy. So what I want you to do at this point is, if you do the next step, we're going to connect our thermistor to our project. So go ahead, get your thermistor and the resistor sewn in there. And as soon as you have that, connect it to your lily pad. And I don't think, I'll come around with the sketch, because I think it was the one sketch that got forgotten. There's a sketch that allows us, there's a temperature sketch. I'll give you the temperature sketch. Use that temperature sketch to read your serial temperature if you don't want to program it yourself. If anybody wants to program it themselves, more power to you.